Hi friends, so in continuation to the last blog, where we had just discussed the concept of linear regression, as promised what we have is a demo in R. So let's take an example of sales and advertisement which we had discussed in the last blog conceptually. So we have sales and we have advertisement, and what we had discussed is sales is our regressant and advertisement is the regressor or the predictor variable based on which we understand that sales can be predicted. Now we're trying to model linear regression, and the hypothesis that we have considered is the sales amount is linearly dependent upon the advertisement value. So we start with setting my directory, and then let me read the file which we are trying to analyze. Now the first step is to plot the data and see if how the dependent and the independent variables behave. So this command would give you a complete scatter plot of all the dependent and independent variables. Since we have only one independent variable in this problem, we would see a plot something like this. So what it gives you is advertisement and the sales, and each of the points are the data points which we have in the current data set. The other way of again basically plotting the data would be with this. We are just trying to put the s, x and the y axes. Next what we are trying to do is plot a best fit line and see how the data looks like. This is an important plot because it gives you a basic idea of the data points against the best fitted line, and it gives you an indicator that yes, our data is kind of linearly related to one another. So we can see that the sales amount and the advertisement are kind of linearly related in this example. Now having said that, we try to model the data. Now what we write is LM is the linear model for R, and we are saying the sales, that is the regressant or the dependent variable, is directly correlated or directly dependent to advertisement. Now if we were to have one more independent variable, let's say advertisement medium, it's a web or a digital media or a print media, we would just add that. Since our data would be factorial, that means categorical, so we would say factor, and we would say the whatever the attribute name is, that is advertisement medium. We would have done that. So because we understand that they are linearly related, so that would have been an additional field had we had that in the data set. Now since we do not, that is we are just having one x to y, we would just model this and see the results. Now the summary command basically gives me the details about the model. So as you can see, for the formula that we have fitted, we have the coefficients and we have the intercepts. So what you see here is the intercept value of 154.50 and the advertisement coefficient, and we see that we have 3 stars aligned at the end, which means that this data or this both of these intercepts and the attribute are really significant. So these are the significant codes which give you the percentages, so we could consider them as more than 99 and above % of significance for both of them. Likewise, if there were to be an independent variable which would not kind of make sense in any of the regressions, you would not see these stars present, and hence that would be an indicator that the attribute is not significant in the current regression hypothesis that we are trying to achieve. So having said that, the next important things is the R squared and the adjusted R squared. To explain this, R squared for first of all would be the coefficient of determination. That means is if we were to go through with this model, how far this model will be able to predict and the score, I mean how efficient would that model be. So currently in this case we can say that it is 99.63% efficient. that is, given the advertisement data, we are able to understand or infer the sales with an efficiency of 99.6, and there is some data, some part of which is not explainable, that would be about 0.4%. And the next important part is the adjusted R square. This is a really important one. To explain adjusted R square, I would suggest let's consider having another attribute or another feature in this design, or as an independent variable. Let's consider again the advertisement medium. As we discussed in this regression, if we were to include advertisement medium and then we were to run this regression again, we would get some coefficient for advertisement medium as well, and we would get a new R square compared to this current model, and an adjusted R square as well. Now if our adjusted R square goes up, which means that the newly added feature or the newly added attribute has a significant exploratory power on the current model that we are trying, or the sales that we are trying to determine. Again, what I mean is, if your R square increases after adding your new attribute or a new feature to the current model, you can safely say that it would be wise for me to go ahead and include that. This is also an indicator for your correlation, understanding the correlation between your independent variables, and also understanding what are the independent variables or the regressors or the predictors which are important for your current model. So that is kind of an example. Now we have understood that, we have seen the summary, and currently we are pretty much satisfied with the results, and we understand this, that we are good with 99.6% of prediction power and predictability. So next, what we do is, once we have successfully been able to establish our hypothesis, we have a new spreadsheet where we just have the advertisements as an independent variable, or the predictors, and we are trying to determine the sales amount. So this would be your input once you have basically established your model. Now having said that, let's try to input the predicted sales value, and next would be predicting. So basically we are trying to predict the new sales, basically the advertisement values against the regression model that we have established. Now these are the predicted values. These are the predicted values for against the inputs for the advertisements, basically 7, 13, 23, 32, 42 and 56 respectively. Now having said that, let's just go back quickly and see. Let's try to establish basically what we have here is we have an intercept of this value. So let's just put this here, and let's just put the advertisement and put it here. Now let's try to determine is equal to this plus this into this, and let's try to basically we are fixing this value. So what we see here is, we see there is a sufficient amount of difference between the actual sales and the ones that we are trying to predict. So let's say we do a diff of this minus this, and then we get to see there's sufficient amount of difference in the actual predicted value again on the trained model. So what you see here is actually the errors. So what we have said is we've already established that there will be an error which will be a part of the model, and which cannot be explained. That is the systematic part of the regression and the non-systematic random errors that we are seeing. So this is what I was trying to draw your attention to, that you can see that the sales amount actually were this, and once the model is drawn, we are close but not we're close about 99.6, but not too close to the actual values. Now going back, so that is what we have done so far, and we have plotted a model, and we have created a model, linear regression model here. Now the next example, we will be taking this into linear regression and into Azure ML, and we will be drawing a model, and we will see how to deploy that into production and make it operational. I hope you're looking forward to it, and I'll catch you soon on the next blog. Thank you.